Hello students, I am Dr. Ravindranath Rajotia and I am taking a course on circuits and systems. In the day's lecture, we will discuss about the type of the signals. In previous lecture, we started with the definition of the signal and the different types of the signals and how they can be represented mathematically. We also studied the detailed elaboration on the different signals such as the continuous versus the discrete signals, analog and the discrete digital signals, random, real time, and the complex valued signals. In the today's lecture, we will study about the remaining signals, and these signals are, let's start with the signals are one that we'll be discussing is a random, and the deterministic signal. Now, what are the deterministic signals? A signal is deterministic if it can be completely specified in or at any given instant of time. So if the signal can be completely specified at any given time, then we call the signal as a deterministic. And if it cannot be specified, it cannot be specified at any given time, then we will say the signal is a random one. Second, if the signal can be completely described, if it can be completely described using some mathematical formulae, then we say that signal is deterministic. For example, if you say that I can completely specify a signal in terms of y of t is equal to, let's say, sine of 2 pi into 10t, where t is described or the given time, where t is the time given. So for any given time, I can find out or I can determine the value of the t. But in the case of random signal, you cannot mathematically write it. So we cannot describe mathematically. The pattern of the signal, that if you plot such type of signal, a deterministic signal, if you plot them, so let's say I will be able to get this value, let's say sine of this value. If you say y is equal to a times sine of this, so I'll say this is yt and this is t. It can be completely. Whereas in the case of a random signal, the signal attains some random values at different instance of time. So you cannot predict, you cannot completely describe such signals. So such as the noise. So if you say noise in a communication channel, so that noise is a random signal. You cannot completely describe it. The second type of signal is the even or odd the signal, even and odd signals. So in signal theory, any signal can be described as the summation of the even and the odd part of the signal. So that means I can say if I am given a signal x of t, I can describe the signal as in two parts. So even part of the signal plus the odd part of the signal. If it is the case of a discrete time system, I can say x of n is equal to x even part of the n plus x into odd part of the n. So what is this even and the odd part? And why do you need to describe this into two components, odd components and even components? Sometimes it so happens, as in the case of the Fourier series, you have the Fourier series in terms of A0, which is a constant, then AIs and the BIs. So all the AI terms are your even terms, and BIs are the terms which are the odd terms. So if a signal contains only the even parts, then I can very easily reduce the number of the terms that can be calculated. So it becomes a simplified, the overall calculation becomes very simple. So also, how do you plot the signals as a odd and even? So I can say if the signal is an even signal, so I will say the signal is even if it can be signal is even if you flip the signal in y-axis. That means if you are given a signal, this in the when you flip it across the y-axis, you will get a signal, let's say this way. So what do you say? The signal which is f of x, when you flip it in the y-axis, I will get f of minus x is nothing but equal to f of x itself. Whereas if the signal is odd, the symmetrically, if you write this signal symmetrically, it has a symmetry over the about the origin. It is symmetric. It is symmetric about the origin. What does it mean? Origin means, so it is symmetric about the y as well as x-axis. So that means if I'm given a signal, let's say I'm given a signal this way, if you write the odd part of the signal, so then I can write this as flip it over the y-axis, it will come here. So let me draw it. So this is a flip on the y-axis. Then across the x-axis, your signal will become this. So mathematically, if you write, so I'll get f of minus x is equal to minus f of x. Also, you can perform number of other operations too. So if you write the even part of the component x of t, so I can describe this as half of x of t plus x of minus t. Similarly, if you write odd part of the signal, odd part of the signal is equal to half x parts of the t minus x of minus t. So if you combine these two signals together, so you should result into the original signal xt. You can try it yourself. So x of t will be equal to x of even part of the t plus x of odd part of the t. So even part is this and odd part is this. When you group them together, when you add them together, so you find that half of xt plus half of xt plus half of x minus t minus half of x minus t. This get cancelled. So if you write it completely, so this will be as half of x of t plus x of minus t plus x of t minus x of minus t, and this way, so this gets cancelled. So of half of xt plus xt, 2 times of xt divided by 2. So this is nothing but x of t. So that means I can say that signal is composed of two parts, even part and the odd part. When you add them together, you get or obtain the complete signal xt. Now let us see the third type of the signal. The third type of the signal is a signal which is wait a minute. Let me erase this one. So the third type of the signal is periodic versus the non-periodic signal. Periodic and the non-periodic signals. So a signal is periodic if it repeats after every fixed interval of time. So that means if I have a signal which is described by this waveform with the pulse width as t, then if the signal gets repeated after every such t width, how can it be represented? It will be represented as another wave of the same width, which is nothing but t. So what do you see here in this waveform? That I have a signal of width t. After this t time, the signal repeats itself. So such type of signal will be called as a periodic. Mathematically, how can we describe this? For the case of the x of t is equal to x of n or t plus capital T, where capital T is the pulse width. So this is the pulse width. So after every this width, the signal gets repeated. So this is the case of a continuous time signal. For a discrete time signal, the mathematical representation will be x of n is equal to x of n plus capital N. The representation in the discrete time signal will be, let us describe it graphically. I have a signal, let's say the value at -4, minus of 3, minus of 2, minus of 1. And let's say now these 4 pulses, the 4 discrete values repeats. So you have a width of 4, -4 to -1. So next time it repeats, the same signal repeats. So I have this value, the second value, the third value, and the fourth value. And after this interval, again the signal repeats. So the signal representation is x of n plus n. So this capital N is the sampling interval. So if the case is a non-periodic, then we say the signal is non-repetitive. So it does not repeat itself after the given or the said time. For example, I have a signal. So this is the signal described of width t. So for it to be periodic, it should repeat after this time t. But if it is a non-periodic signal, the signal will not repeat after the fixed interval of time. It may repeat at a random instant of times, but not at fixed intervals of time. In those cases, if the signal representation is, let's say this is my t, and this repeats maybe at some random instance of time, since it is not repeating after every fixed interval of time, I say that this signal is a non-periodic and cannot be represented by the x of t plus capital will become false for this condition, and hence it is a non-repetitive signal. Okay, fine. With this, we complete all the different types of these signals. We started with the basic signal, continuous versus the discrete signal, then analog versus digital. Then we said real valued and the complex valued. Then we came to the another type, deterministic versus the random signals. Then even and the odd part of the signal, and finally the periodic and non-periodic. Hope the concept is clear to you. Thank you for watching.